Okay, folks, our final set of screencasts on limits and continuity. And what we're going to do here is we're going to analyze these questions and see if we can come up with some answers. So here's the first question. For what values of p does the limit as x approaches p on the positive side, so on the right, g of x equal 1? So like reading this notation is so loaded. We have to remember that the answer to a limit is a y value. So it's saying when is the y value 1 as I approach from the right, okay, p on the positive side. So what's that value of p? And this is going to be an x value, right? So the first thing I would do is just go down to g and make a line across at 1, right? There we go. So that's the line y equals 1, right? And that takes care of this. That's what we know what that is. So, and actually I put over here, what's a non-symbolic way of saying this? What are the x values where y equals or approaches y equals 1 from the right side? So let's start going through this. So I'm going to approach from the right side. So that means I start from the right of the graph, go down until I hit y equals 1. Well, look at that. There's the first time I do. First time I hit y equals 1 is at 3. So p equals 3. There's one value. Then I keep going and keep going and going. And here, do I hit 1 from the right there? I don't think so, right? 1 is from the right, the y value goes to infinity. Here, it's approaching y equals 1 from the left. Keep going, and I hit 1 right here as well. Where does that look like I do it? Looks like about negative 3.5. So this actually is not a tough problem, right? But it's reading all this notation and representing it graphically. Okay, so I'm starting at a y value of 1. So I drew a horizontal line at 1. Then it said I was coming from the positive or right side. So if I look here, as I come from the right side, yep, x equals 3 works. Come along here, I hit y equals 1 here, but this comes to y equals 1 when I'm approaching from the left, the negative side. Keep going, and look at that. I hit y equals 1 here in this part of the curve, and I'm hitting it halfway between negative 3 and negative 4. Okay, let's look at number 8 now. Now, number 8 is a really interesting one. So let's look at what does f at negative x mean. So it says find the limit for f of negative x as x approaches negative 1 on the negative side. Lots of negatives. Well, do I have a graph of, or do I have an equation for f at negative x? No, I have an equation for f of x. Okay, everything is defined in terms of f at x. And even I'm supposed to use f at x, this version of f at x, if x is less than or equal to 1, this version of f at x, if x is greater than 1. So what am I going to do? Let's think about this. Is there a way that I can write this in terms of f at x? So let's draw just a Cartesian coordinate system. And what I'm going to do is I'll draw a couple of points, like say that this is at 1, and we'll say this is at negative 1, and then I will draw a graph. So f at negative x means a horizontal reflection. So if this was a graph of f at x, right, the graph of f at negative x, I'm switching the value of x, right, to make it negative. So when x is equal to 1, then f at negative x means I go to negative 1. But I still have the same y value because it says f at negative x. So the y value is not changing sign. So it's the same y value at the opposite x value, right? So that means, let's see, I can do this. So I come over to here, and now it would look like this, right? So it's a mirror reflection. That's a horizontal reflection, f at negative x. So this right here would be f at x, and this over here is f at negative x. Okay, that's f at negative x. So what do we notice? Okay, what do we notice about this? F at negative x, f at x. So if I'm approaching, look at this limit here. If I'm approaching -1 on the negative side for f at negative x, let's see. So I'm approaching -1 on the negative side. So I'm coming down here from the negative side. The answer is going to be that y value there. Well, what's that equivalent to for f of x? Well, I'm going to get, because these are vertical reflections, mirror images, or horizontal reflections, that's the exact same limit as f at x approaching +1 from the positive side, from the right. So here's what we do. We write this, that it's the limit as x approaches 1 from the positive side for f at x. Right? It's the exact same thing. If I'm on f of negative x and I'm approaching -1, I'll get the exact same y value as if I was on f at x approaching +1 from the positive side, right? Everything on x switches. A horizontal reflection is switching the sign of x. Not y, but x. So this negative, and this negative are all going to change. Okay, so now, can I do this? Do I have information for f at x as x approaches 1 on the positive side? By the way, which curve would I use, or which equation would I use on the positive side? Well, this says x is greater than or equal to 1. That's to the right of x equals 1. So if I'm on the positive side, I need to be using this. So what it's really saying, the limit as x approaches 1 on the positive side for x cubed plus 1. Well, I can just substitute directly. That's not an indeterminate limit. So it just becomes 1 cubed plus 1, which equals 2. Okay, so that's where an understanding of reflections is really helpful. So if you're being asked to find the limit of f at negative x, all you do is the limit of f at x, but switch the sign and the side of the x value in your limit where you're approaching. Okay, so if this is f at negative x, change this to f at x. If this is -1, change it to +1. If it's coming from the negative side, change it to the positive side, and then it becomes a very easy question. Okay, folks, so hopefully that helped. A bit of reflections there, and then this question up here, number 7, is just about reading limits left and right correctly.